Hey guys, so this is the second part of the video where we're solving this question, but now we're not doing using the graphical way, but we're just, finding the integral. So again, as the question says, f function of x and y is under root 4 minus y square, and the r is 0, 2 times 0, 2. So this means, x changes from 0 to 2, y changes from 0 to 2, right? Okay, so the volume would be, the double integral of f x y. So since it's a rectangle, it can be changed to iterated integral. That's exactly what I've done here. So it goes from 0 to 2, 0 to 2. Since, the limits for x and y are the same, it doesn't really matter here. 4 minus y square dy dx. Let me use a different color. Okay. So now we have 4 minus y squared under root. So you guys must have learned this in Calc 2 about trig substitution, and I think it's the easiest way to go about this problem. There could be other solutions, definitely, but this is what came to my mind first, so that's how I went with it. So in this case, use let y to be, so this is, let y to is as 2 sine theta. So since it is in the form under root a square, where a is a constant, minus y square, you let y to be a sine theta. So in this case, a is 2, so that's what I've done. And then, dy is 2 cos theta. The derivative of sine theta is cos theta here, so times d theta. So that's that. And theta, from this relation, theta is equal to sine inverse y over 2. So again, that's that, just some relations that should be useful in solving the problem. And how did I find cos theta here? So, the hypotenuse is 2, the perpendicular is y, and the base is under root hypotenuse whole square minus perpendicular whole square. So under root 4 minus y whole square. Cos theta is base over hypotenuse, so it is under root 4 minus y square whole divided by 2. So again, this should be useful. I'm not really sure. Let's see if it is useful or not. So again, let's start with this integral here. So indefinite integral, and then we'll put it into our definite integral later on. So, okay, under root 4 minus y squared dy. So I've changed this. I've used the value of y square to be 4 square sine square theta, taken 4 common here. So 4 parentheses 1 minus sine square theta. Again, we know that relation. It is cos square theta. So that's what I've, replaced here, and dy from here is 2 cos theta d theta. Okay, so that's done. And cos square theta would be 2 cos square theta is cos 2 theta plus 1. So I've used that relation, cos 2 theta plus 1. And since, 2 will be common for both, multiplied by 2. So what I'm saying is 2 times 2 cos square theta, that is 4 cos square theta, and this is 2, oh, so no, just cos 2 theta plus 1. So that's what I've done here. And now the integral of cos 2 theta is sine 2 theta divided by 2, again standard integral. And the integral of 1 with respect to, d theta, it would be 2 theta. So this 2 cancels this 2. So we are then left with sine 2 theta plus 2 theta plus c, since this is uh, indefinite integral. Yeah, that was the word I was looking for. Indefinite integral, you have to use c, but in our question, we'll not be doing that. Again, since we were given this question in the form of y, we have to take theta back to y. So that's exactly what I'm doing here. Sine 2 theta is 2 cos theta sine theta. And yes, we now have to use the value of cos theta. So 2 times sine theta. Sine theta is y over 2. Cos theta is 4 minus y square under root divided by 2 plus 2 theta. So the value of theta is this plus c again, and you further simplify it and you get equation 1. That's important for us, using equation 1 in our solution. So now we go back to this equation because that's the one we're trying to solve, right? So we know that this gives us this, and now we just use the limits that we have, 0 to 2. So I've done it here from, from 0 to 2. So if it is like, let's say, x 2 to 0, what you do is 2 minus 0, right? That's what you do. So the upper limit minus the lower limit, and you just, input the value of the variable. So here in first case, you replace all y's with 2. That's exactly what I've done. And minus, replace all the values of y with 0. So that's again what I've done here. So 4 minus 4 is a 0. So this automatically makes it 0. Here everything 0. So 0, 0. And sine inverse 0. What is sine inverse 0? That is 0. You can look into the trig table, right? And 2 times 0 is 0. Now the only value that we non-zero value that we get here is sine inverse of 1. What is sine inverse of 1? That is 90 degrees, or pi by 2, right? So 2 times pi by 2. So this 2 takes out this 2. So we are left with pi. And this is finally what we get. And again, the pi is a constant, so pi goes out, and then integrating 1 dx would be x, and it's going from 0 to 2, so it would be pi times 2 minus 0, which is 2 pi. That is the final answer. That is exactly what we had gotten using the graphical method. Again, this took us like 7 minutes, I guess, but that one took us like 2 minutes. But then again, both methods are absolutely correct. It just depends which method you want to go with. I'd recommend the first one, but again, second one is correct as well. So yeah, thank you for joining me on this one, and hope to see you in my next videos. Thank you.